Alright, so this pretty much tells you what you need to do. If we're going to take a derivative of a polar equation, we have to convert it to parametric first, so that we can get an x and a y, and then we can find the derivative by taking dy d theta divided by dx d theta. So using the parametric form to find the derivative. So what we want to do here is we can see what r equals, and so if we solve this, these are the formulas we want to remember for x and y. So if we divide both sides by cosine theta here, we would have r equals cosine theta. And now we can substitute this in for r. So we would have that, and I was thinking about skipping a step there, but so if we replace that, and then we can multiply both sides by cosine. So it's going to be like that. And so now we have x, and then we do the same thing basically for y. So divide by sine, so we have y over sine equals r, and make that same substitution. It's going to be 3 minus 2 cosine theta, and then multiply by that. We'll have 3 sine theta minus 2 cosine sine. Okay, so that pretty much takes care of that. Now we can go ahead and find dy. Let's keep that in red. So dy d theta is, if we take the derivative of this, 3 cosine theta. Derivative of sine is cosine. Now here we have to use the product rule. So we're going to take the derivative of the first thing, which would be negative sine. So we'd have a negative times a negative, so that's going to be plus 2 sine squared theta. So we take the derivative of the first thing times the second thing plus, but we have this negative 2 here, so plus negative 2 times the first thing times the derivative of the second thing. So the derivative of the second thing is cosine, so cosine times cosine is cosine squared. Now, I did skip a little bit there, combine some things, so if you're confused on that, come to office hours and I'll write it out here for you. Okay. Now that's going to be over dx d theta. And so this is basically the same thing we did in that parametric lesson. So now we're going to take dx d theta. So the derivative of cosine is negative sine, so that's going to be negative 3 sine theta. And then if we move over here and take the derivative of that, we're going to bring that down, so that's going to be negative 4 cosine theta. This is the chain rule, so the outer function is squared, and now we have to multiply by the derivative of the inner function, which is going to be negative sine theta, which will make this positive. Alright, now, because we are evaluating this at a specific point, we can just go ahead and plug that in right now. So the cosine of 0 is 1, so that's going to be 3. The sine of 0 is 0, that's going to be gone. And the cosine of 0 is 1, squared is 1, times 2 is 2, so that's going to be 3 minus 2. Suppose I could have put a plus 0 in there, maybe. I don't know if that helps. And then minus 2 like that. And then down here, this is going to be 0. And then the cosine of 0 is 1, and the sine of 0 is 0. So that's going to be 1 over 0. So the derivative at 0 is undefined. Okay. Now, if we think about this, if dy dx, if dy d theta equals 0, then the horizontal will have a horizontal tangent, because it's telling us that this, if we get 0 for the numerator, then the fraction is equal to 0, which is a horizontal tangent. If dx d theta equals 0, like it did here, then we'll get a vertical tangent. Okay. So we can try this out. So if we look at this, and R is x over cosine. So this is x over cosine, and then we multiply both sides by cosine. So that's going to be 4 cosine squared theta. Okay, so this says find all the horizontal and vertical tangents for this polar curve. So I already found x, so I guess we're going to find the vertical first. So the vertical are when, remember, when dx d theta equals 0. So if we take the derivative of this, that's going to be 8 cosine theta times the derivative of this, which would be sine theta, except that would be negative. So we can set this equal to 0 and divide both sides by -8. And so now we can say, okay, when does this cosine of sine, is cosine of theta times sine of theta equal 0? Well, it's equal to 0 anytime either one of those are 0. So that's going to be at 0, because sine is 0 at 0, and cosine is 0 at pi over 2, and sine is 0 at pi, and cosine is 0 at 3 pi over 2. So we're going to get those 4 angles, and then if we go back and put those into the formula up here, so we'll have 4 times the cosine of 0. Cosine of 0 is 1, so that's 4. So that is, remember, r comes first, so that's 4, 0. And then if we plug in pi over 2, we're going to get cosine of pi over 2 is 0, so that'll be 0. So r will be 0 when we're at pi over 2. And then if we plug in pi, cosine of pi is -1, so that'll be -4 when the angle is pi, and finally that last one will be 0 when we plug in 3 pi over 2. Okay, so those are the points. Find the points where they're vertical tangent lines. Okay. Now let's do the horizontal tangent lines. So the horizontal tangent lines are where dy d theta equals 0. Okay, so if we look at r as y over sine theta, and we multiply both sides by sine theta, we get 4 cosine theta sine theta. Okay, horizontal are when the derivative equals 0. So if we take the derivative of that, we're going to get, let's see, 4 times the derivative of the first thing, which is negative sine. So that would be -4 sine squared. And then plus 4 cosine times the derivative of the second thing, which would be cosine. So that's 4 cosine squared theta equals 0. Now this is a little bit trickier because we need both of these things Well, we can rewrite this, so we could divide the whole thing, or multiply the whole thing by 1/4. That'll get rid of those 4's. And then we could flip-flop that, so just so cosine minus, so we have one less thing to worry about. Okay. Now, if you recall, one of the tips for solving trigonometric equations is to get it to a product, or to get it all to the same kind of trig function. So I'm going to switch sine squared to 1 minus cosine squared. Back with the Pythagorean identity, sine squared plus cosine squared equals 1. So sine squared equals 1 minus cosine squared. So we're going to make that substitution there. So now, if we distribute this, that'll be positive. So we'll have 2 cosine squared theta minus 1. And if we add 1 to the other side here, we'll have 2 cosine squared theta equals 1. And divide by 2, so cosine squared equals 1/2, and square root both sides. So we're going to get the absolute value of cosine theta equals root 2 over 2, and then cosine theta equals plus or minus root 2 over 2. So if we think about the values where that's going to happen at all the 45, pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Alright, and so if we plug that back in, that's going to be, so we need to calculate r. So r is right here, so if we plug in pi over 4, we're going to get root 2 over 2, which is 2 root 2. So that's going to be 2 root 2 and pi over 4. And we move over 3 pi over 4, cosine of 3 pi over 4, that's going to be negative root 2 over 2. So this would be negative 2 root 2 for 3 pi over 4. And then when we go to 5 pi over 4, that's also going to be negative. So we're going to have that. And finally, the last one at 7 pi over 4, cosine of 7 pi over 4 is a positive root 2 over 2. So those are our points where we have a horizontal tangent line. To find tangents at the pole, it's a pretty straightforward process. We're going to set r equals 0, solve for theta, and then theta equals each of those angles. Those will be the tangents. So that's pretty straightforward. So we'll let r be 0, and we have this. And then we will subtract 3 and divide by 3. So we've got cosine theta equals negative 1. And so that happens at pi. So theta equals pi, that's a line, the tangent line. Now if you want to take a look at this, it actually kind of, I'm going to draw it horribly, but kind of goes like that. Alright. And so at the pole, we have a tangent right there for pi. Okay. And again, so set this equal to 0, 2 cosine. So we can divide both sides by 2. That doesn't really have an impact on the angle there. So we need to know what values. So we need 3 pi to equal, so this is for theta between 0 and 2 pi. Okay. And down here we're going to get cosine of 0 at pi over 2, and 3 pi over 2, and 5 pi over 2. Okay. So if we multiply both sides by 1/3, we're going to get pi over 6 and pi over 2 and 5 pi over 6. Okay. So really we should write those out separately because each one is a separate line. So we have that and we have this. We want equations of lines. So this is what we need here. Now, if you were to look at that one, it kind of looks like one we did, the rose curve, except it goes this way. Oops, I didn't do that very well. It swoops out here, goes like that, and then like something like that. Those all should be the same size leaves there. And so if we look here, that's going to be here, and if we multiply that by 3, we get 3 pi. So that just helps us know what angles we need to get through that whole rotation there. Oops. So we'll see as we review if they actually ask a question about a tangent at a pole as we review the AP test. So we're down to our last lesson. It's about that time. Have a good day. One lesson to go for Calculus BC.